So let's continue with our discussion of assignment 4, question 8 and 9. Question 8 and 9 are how many number of ways are there on a grid? So the first question is like we have a city block pattern. It's also called Manhattan pattern. It's just like we have different sectors like in Islamabad we have, it's called Manhattan because in New York Manhattan the structure of the area is just like in the shape of blocks, square blocks. So we cannot move along the diagonals, we have to go along either in vertical direction or in horizontal direction. So in this problem they said that in north south directions we have got streets. So in north south direction we call these as streets, and in east west directions are called avenues. So we have got 20 streets and we have got 10 avenues. So in other words, if you look at this grids, we have got 20 columns and we have got 10 rows. So if we start from this bottom point 1 1 and we want to reach to this right top corner, so its coordinate become 20 10, like 20 along x-axis and 10 along y-axis. So in how many ways we can reach if we have to follow these patterns along the grid? We have to follow the streets and avenues. So in how many ways we can reach till this point 2010? So it's just like one possible way could be I go from here straight in the first street and then I take the 10th avenue and I reach here. But we can have many number of ways. I may go till here and then I take a turn, take this route, and then I take turn, take this route, then I come to this avenue, and finally I took this street to reach here. So similarly you can define some other ways. So to count the number of ways, one good way is to use the analogy of 1 and 0. Like I'm keeping record. Whenever I'm going up, so I mark a 1. Whenever I'm going towards right along horizontal direction, I mark a 0. So if I go one block up, I mark it 1. If I go again up in upward direction, I mark it again 1. And as soon as I go towards right, so I will mark 0. So it's just like combinations of ones and zeros. So how many ones and how many zeros I am going to get? This is one question. So whenever I go up, I get 1. Whenever I go to right, so I get a 0, a 1 and a 0. So how many times I go up? So there are like 10 avenues. So 10 times I go up, and how many steps I have to go towards right? 20. So there are 20 zeros. So if we move n times upward and m times rightward, so I will get n ones and m zeros. So I will get a bit string whose length is m plus n. So m ones and n zeros, n ones and m zeros. So I will get m plus n length binary string in which I have exactly n ones or m zeros. It's same thing. So a binary string whose length is m plus n. A binary string whose length is m plus n. It contains exactly n ones. So how many binary strings are possible? Remember from the first part of assignment, if we have a binary string of length n and it contains r ones, it means out of n objects we are marking r objects. We are picking up r objects. So how many such binary strings are possible? N choose r. Among n possible bits, I have marked r bits as 1. So I can get n choose r such binary strings. Now I have length of binary strings m plus n, in which there are exactly n ones. So how many such binary strings are possible? So answer is clear. It should be m plus n, choose n. Problem 9 is at least it's part A. The first part is quite similar. The first part says we have the word mathematics in this grid, in this table. So in how many ways we can form the word mathematics? For example, I can move along this direction, and then I go here, mathematics. Or I can make some other combination, like I may go from here, and then matics, like this. So we have got mathematics. Or I can take some intermediate, mat, and then I have hem, and then I have ati, and then I have cs here, mathematics. So it's exactly like the previous question. It's like we have to move along the grid, along the square blocks. Whenever I go down, I mark a 1. Whenever I move towards right, I mark a 0. So in how many ways I can reach to, from starting from the starting point, our m, and reaching till the last point, which is s. In how many ways I can reach here? So again, we can use as ones and zeros. I mean, I can go in different ways. So whenever I'm going down, I mark it with 1. Whenever I have to go towards right, I mark it with 0. So how many ones I'm going to have? So how many down arrows I may get? M to A to T, T to H, H to E to M. So I can have 5 ones, and I can have 6 arrows in right direction, 6 positions, 6 steps in right direction. So I have 6 zeros. So we have got a binary strings whose length is 5 plus 6, 11, in which we have exactly 5 ones. So how many binary strings are possible with a length 11 and 5 ones? So answer is, you know what is the answer. Okay, so let's look at this the same problem in a different way. So I'm standing at m. In how many ways I can go to m? Of course, I have to start from m, so there is only one way, that we are going to start from m. That's fine. In how many ways I can reach to, for example, this a, from m to a? So there is only one way, that I move towards right. There's no other way to reach this a. Similarly, in how many ways I can reach to this a? From m I can move to a. So there is only one way to reach to a. So that's fine. So I'm counting in how many ways I can reach to each of these letters from starting from m. So in how many ways I can reach to t? In how many ways I can reach to t? So from a to t there is one way. From a to t there is one way. From upper a to t, or from left a coming to t. So from starting from m coming to t, how many ways are there? From m coming to a and then coming down to t, this is one way. And from m coming down to a and then come to t, this is another way. So I have got 2 ways to reach to t. My route, one route could be following m to a and then coming down a to t. This is one way. The other way is from m to a and a to t. This is second way. So I have got 2 ways to reach to t. So I label these my ways of reaching these points. So I have marked it 2. Okay, so if I move along, so in how many ways I can reach, for example, to this t? In how many ways I can reach to this t? So from m to a there's only one way, and then a to t there is only one way. So there's only one way to reach this t. I start from m, go to a and come to t. So this is only one way, which has 2 steps, but way is only one. Similarly, in how many ways I can reach to okay, so in how many ways I can reach to, for example, this h? So in how many ways I can come to h is one way is from T I can go to H. This is one way. The other way is from this T I can come to H. This is another way. But till T, in how many ways I can reach? There are two ways, M to A to T, or M to this A and A to T. Two ways to reach to T, and then from T to H there is one way. So total to reach to H there are three ways. So which three ways? M, A, T, and then T to H. This is one way. Second way is M to A and A to T and follow on to H. This is second way. And third way is M to A to T, and then T to H. This is third way. So there are three ways to reach to H. So in general I can say at every stage we add the previous number of ways from where we are reaching. So we have to add these two numbers. For example, in last case for H, from till T there is from T to H till T there is one way, so one way, and from this T there is two ways, so 1 plus 2 is equal to 3 way. Let's look at some other one. For example, this T. For example, this T. So there's only one way, from A to T I come here. Okay, and from this T to H, so from this T to H I can come from like this, or I can come from this side. So till T, number of ways we are counting from M. From M till T there is two way, and then one way to come down to H. So this is total two ways, and one way come from this side, M to A to T and T to H. This is one way. So total ways are 2 plus 1 is equal to 3. Similarly, look here for this E. From M to A to T till H. This is one way. In one way I reach till here. So from here H to E there is one way. Fine. So till this H I have three ways, and from H I can go to E one way. So total ways are 3 plus 1 is equal to 4 ways. Similarly, for this E we can see from H to E I can come, or from this H to E I can come from this side. So till this H I have three ways to reach, till this H I have three ways to reach. So till E I have total of 6 ways to reach till E. Similarly, if I have to count for this M, so I have to see till E I have 4 ways, and till this E I have 6 ways. So 4 plus 6 is equal to 10 ways to reach till M. So isn't it like Pascal's triangle? In Pascal's triangle, if you remember, we add, okay, so in Pascal's triangle we add two points to get 1 point at the bottom, two coefficient, two number to get 1 point below them. So at any stage we add two numbers to get a number under them. So if we have one number, so it is sum of immediately above two numbers. So over here also we are just summing up the numbers above our we are just summing up the number of ways till the letter before the current letter. For example, if I have to look in how many ways I can reach till this T, so I have to see in how many ways I can reach to A, in how many ways I can reach to this A. So number of ways to reach to this A plus number of ways to reach to this A is equal to number of ways to reach to this T. Or for example, yeah, like till the last S. So in how many ways I can reach? So in how many ways I can reach till this C starting from M? In how many ways I can reach till this C starting from M? So add these two ways to get S. So if we I just draw some diagonals because our grid is not in the shape of triangle. We can write down in shape of triangle as well, little adjust it, it will be just a little rotation. So uh, these are number of ways corresponding to all these letters in the above grid. I have put number of ways over here. Till M I have one way, till A, so again I have only one way to reach to A, from M to A. Next I have T, so till T I can reach only in one way, just coming down, there's no other way. Similarly over here in the horizontal direction, this is the last M over here, so there's only one way starting from M, coming down, coming all the way here, so there's only one way to reach till M. So like we have discussed, till T I can reach in two ways. So I place a 2 here, and at every stage I have to add the two numbers immediately above it. So to get 2 I have to add this one and this one. To get 3 I have to add 1 and 2 is 3. To get 4, 1 plus 3 is 4 at any stage. For example 70, so it's 35 plus 35 is 70, so 21 plus 35 is 56, 56 plus 70 is 126, 126 and 126 is 252. So this is the number of ways. At every step it tells us number of ways how to reach from our starting point M till some particular letter, in how many ways we can reach till there, and overall when we reach till the end, so it will tell us in how many ways we can reach from M till the last letter S. So can you write all these numbers in terms of binomial coefficient? This should be easy. So following the same approach, we can solve the B part of it, in which we have got mathematics with certain numbers, certain letters missing. It means we cannot go in this region. These are missing, these are missing over here, these are missing, these are missing. So there are no ways to reach here. So if I have to come to I can only come from T to I. I can only come from T to I. I have no way to come from the left side, so this is not possible. So how to make number of ways for this? Again following the same pattern, those letters which are missing we have to put 0 over there. So like over here these letters are missing, so I have to put zeros for those letters because we cannot reach over there. And after that it is exactly the same pattern as before. So from 1 I can reach, from M to A I can reach in one way, again to T I can reach in one way, till H I can reach one way. After that there is no letter over here, we can see there's no letter after this, so I have to put all these zeros around here. So after that from H to E there's one way, so and from H to E there is one way. So till H, this particular H, in how many ways I can come to this H? There are 3 ways, and these all come from the same way of addition we did before, like 1 and over here also 1, so 1 plus 1 is equal to 2. Similarly 2 plus 1 is 3, so 1 plus 3 is 4, 4 plus 0 is 4, 4 plus 0 is 4, 4 plus 4 is 8, and so on till we reach till the last point S. So it's again exactly same like Pascal's triangle, but with some missing values, but otherwise all the rules are same. So I mean, this problem is solved, so you can just do it. And the important thing is you should understand how we are approaching this problem. So thank you very much for this part.